Hello to everyone, my name is Elwin Huaman and today I will talk about what are knowledge graphs and how they can support under-resourced languages. The outline of my presentation starts why we are building knowledge graphs, why it's important for under-resourced languages, how they can be built um, and what are the approaches that we have taken in regards to the Quechua language and what we can do as a next step. So why knowledge graphs and under-resourced languages, why they are important? So under-resourced languages are languages that have a limited amount of resources and they struggle to be supported by the pace of technology, are somehow marginalized by society, and minoritized by dominant languages. Basically, there is less implemented on language technologies. Basically, they have less fonts, keywords, they are not fully supported by NLP tasks, not graphical user interface, and in general, under-resourced languages they are not well adopted on technologies, and they have they could have a bigger community, but not enough to empower this technology. So they are becoming dependent on dominant languages. In the case of South America, for instance, they are becoming dependent of the Spanish and Portuguese, and the indigenous languages are also not official language in their own territories. Also, so they suffer a consequence of colonialism. Of course, they are minoritized because they are isolated in the Andes, perhaps in the case of the Quichua language, and they are excluded from decision-making processes. So they live in places where the technology never arrives. Now, what are knowledge graphs? Knowledge graphs in the computer science field is defined as very large semantic nets that integrate various and heterogeneous information sources to represent knowledge about certain domains of discourse, and it means that every statement that we could speak can be transformed as a triple. So a triple is composed by a subject, predicate, and object, and in this case we could have the University of Innsbruck as the subject, is located in as the predicate, and the city of Innsbruck is the object. So every statement that we could say can be transformed as a triple, and in the case of in making this statement much unreadable, we just need to use some standards and ontologies in order to make it as an RDF triple, which is a standard for resource description framework. Well, knowledge graphs basically they can be started as a statement, simple triple. Anna is enrolled in a specific CS 101, and Anna also has more information. The birthplace has the age, has the what is it about the subject, programming, and so on, and they are specifically categorized and classified. Then more information or more statements can be added into these graphs, creating more connections in between the objects, between the persons, between profiles, between places, and so on. Those knowledge graphs also can be created independently. Since they are using a common format, common standard, they can be linked together. So basically we have two different graphs and they can be connected with certain relationships between them, forming a bigger graph. So currently, knowledge graphs are well adopted by technologies like Facebook, Amazon, Google, and so on. They have their own knowledge graphs. Even Wikipedia has its own knowledge graph called Wikidata, and they are using well adopted standards and tools as well, like a proper schema for search engines, proper resource description framework for describing or representing knowledge and language, and for describing lexicographical data we have Ontolex Lemon as well, and on platforms for graph databases we have Wikibase, GraphDB, and Neo4j, and so on. So how one can build a knowledge graph for underresourced languages? So there is a well-established knowledge graph creation lifecycle, which starts with the knowledge creation, knowledge hosting, knowledge curation, which is the hardest step, and then the knowledge deployment. What it means that once we build a knowledge graph that we, as we see in the middle image, so we can empower applications such as search engines, NLP tools, user interfaces for that knowledge that is represented into the knowledge graph. So if it's the knowledge graph for an underserved language, then it could immediately power applications on top of it. For the process of creation, we identify resources, basically dictionaries, vocabularies, and so on. And for the Quechua language specifically, we found a dictionary called Runasimi, and they have translations, they have linked to other Quechua variants, they have information about the adjectives, adverbs, pronouns, suffix, verbs, and so on. Then also we start to model in the data how we could represent our data in our knowledge graph. So base it on some specific standards. So we take the Wikidata lexicographical representation ontology and vocabulary, which is based on Ontolex Lemon, and we start to describe it lexemes. For instance, it should have a lexical category, it should have forms, it should have senses, and so on. So those are mandatory fields that every lexeme in Quechua language, for instance, should have. Then we have the hosting stage where we should store our knowledge base basically, and it should be powered in a way that it also allows a good service time wise, because sometimes a lot of people are connecting to this knowledge base, so it's necessary to have a good service there, a good host. So in this case, if you want to adopt an open source technology, then you can definitely use Wikibase, which also powers Wikidata. So it's a good approach to start with this technology because they are already well used and well maintained as well. Then in the curation stage, we also have some technologies around the Wikimedia ecosystem, and OpenRefine is one of them. So basically, in the curation step, what we can ensure is that there are no, for instance, duplicates, there are no errors, there are no messy data. So once we find a dictionary in our language, then it could be clean, it could be pre-processed, and then it could be reconciled with existing knowledge. So it avoids to make duplicates in that sense. Then we have also another options to import data into the knowledge graph, which is Wikibase import. So not lexeme by lexeme or word by word, but as a bunch, as a import data sets as a files, for instance CSV files or more structured data files as well. And also there is also entity schemas that could also be configured in a way that it could validate the data that is ingested into the knowledge base. Then we have the deployment stage where our knowledge graph of our language basically can be used, in the sense that, for instance, users can query the knowledge that exists. They could see it in the phone. They could ask questions, and they can, of course, explore the senses, the forms that they contain, and they can start to search on it. Not only that, because it also provides a more advanced Sparkle endpoint or access endpoints like a Sparkle, where you can ask queries, and those queries can be transformed into a specific result, like a forums, charts, and very graphs, very nice graphs that could be very useful for representing or showing the data that is ingested there. So building a knowledge graph for under-researched language, it's composed by these four steps as we mentioned before. So it's the creation stage where we start to collecting and modeling the data, hosting where our knowledge will be served, the curation to ensure the quality of our data, and the deployment, who will use it and how we make that they use and take advantage of this knowledge. So what we have done with Quechua base is we create the Quechua language and knowledge graph, which basically, going back a little bit to about the Quechua language, it's based in the South America mostly, and it comprises around 6 countries, and the speaking population it's around 9 million people. However, there are around 20 dialects and variants between the Quechua language, so it's not really easy to standardize all of them. So every language has to be represented on its own way. And regarding language technology, basically there is a general translator, but the translator does not identify which variant it is or which dialect. There are some fonts and keywords developed for the Quechua language, but there's not much use of it because no one is aware about it. And there are no interfaces on social networks. For instance, if you go on Facebook or TikTok or Instagram, they don't have an interface in Quechua language. They're not covered, of course, by NLP. Just every researcher is doing their own research on this aspect. And social and institutional aspects, the Quichua language is dependent on Spanish, and now it's borrowing a lot of words from this language. And it's not an official language in Peru. It is in other countries, but not in Peru. And it represents nowadays a minoritized community. So our current Quechua base is shown as you can see in the screens. Uh, Everybody can consult the desktop and the mobile phone versions, and everybody can contribute and ask questions on the Quechua base. So currently there are around 1 million of statements, lexems about nouns, verbs, and adjectives. More than 20 Quechua dialects are stored in the Quechua base. They have senses in English, German, and Spanish, and they are accessible by quechua.wikibase.cloud. So for instance, here we have three different lexeme representations for one specific word. So this is possible, and also to mention that we started to add the speech pronunciation or the pronunciation audio for each of these lexemes in specific variants. So this is quite useful and is accessible as well nowadays. So as next step, what we have now is the deployment stage, where we encourage to deploy this knowledge graph. So since we have knowledge graph stored openly on the web, so basically search engines can start to collect data from in Quechua language for and show them as a result on the search engine. So instead of having these knowledge panels that are at the right side, so this could be in Quechua coming from the Wikipedia, but also the place of birth, the H index, education, and so on could be also replaced for Quechua lexemes here if they are well represented there. Then also having a knowledge graph also allows search engines to collect the data and represent it on an easy way and concise way for the users. Then we have also chatbots and personal assistants that they can, if today we ask to in Quechua language to a personal assistant, they will definitely not answer because they will not be able to understand the Quechua language. However, if we power this virtual assistants or personal assistants with a Quechua knowledge graph, then they will definitely understand our language, and at least they will start to try to empower our language and use our language there. Of course, the interfaces of social media also will be deployed as a consequence, because currently at least Google shows offers a Quechua version of the Google search engine. However, not all the words are translated. For instance, not on the menus. For instance, there is all in English, Tichtucucuna in Quechua, and then you have videos, books in English. So several languages are mixed up in one single interface. So this is a call to attention for Google basically. And as a conclusions, I would say that in the technical aspect, we face that data is not clean, and in under-researched languages, we mostly face with pre-processing the data, or finding no resources of it. So we have to scan this and process the data and make it available. Then the modeling is challenging because every language, of course, has their own peculiarities. So it's not easy to have, but we could have some starting points with Ontolex Lemon, for instance, and start populating our knowledge graph for our language. Then it's a good idea to familiarize with knowledge graphs as well, because it's a technology that it's seen very useful uh, to to act as a common sense for responsible AI applications in the common years. Then we also, of course, encourage the human in the loop, because when we talk about our language, we will not try to just to put data bilingual text on the web, or creating corpuses of bilingual text, but we encourage the humans can curate this data, because with Quechua base, for instance, everybody can enter to Quechua base and add new lexemes, but also they can update the information there, they can correct, they can curate the knowledge base there, of course. Then, of course, the most challenging part perhaps is the provide cost-sensitive methods, because having open source technology, it's very good, uh, but hopefully it works forever, and if does not work, then it's a challenge. It's a really a challenge. In the social aspect, I think there are building a community. It's a huge step because it's not easy to find a community that supports this technology. Of course, there could be users, but it's not easy to find a community that builds up or continues the development and maintenance of these knowledge graphs. And the language status, of course, it's also in a step that it's shifting from the Quechua to Spanish, for instance. And of course, what we wanted with other source language knowledge graphs is bringing in awareness and demand interfaces or applications in our mother tongues or indigenous languages. And we, of course, claim the web for all, not only for English or Spanish or dominant languages, but a web for everybody. So I just want to acknowledge the University of Innsbruck, Wikimedia Foundation, Wikitongues, Cost Actions, Nexus Lingual in Unidive, and Kitsch Experience, and the community, Yari community in Uñoa, in Puno, Peru, that help us to collect the voices, to collect information, dictionary vocabularies in Quechua language. Thanks to all of them.